Okay, now we talk about the general features. Now we talk about general trends. All right. So once again, general trends, we all know the metallic and non-metallic character, right? It changed from metals to non-metals across a period. What else? All right. So metals and non-metal, and it passed through the metalloid, number one. Number two, and this keep coming out. All right. I'm going to put a star here, nature of the oxides. We learned this in acids bases really. Ready? Ladies and gentlemen, sodium oxide is a basic oxide. Magnesium oxide is also a basic oxide. And I would like to tell you all, they always test you period 3 oxides. Write this down, everyone. They won't test you period 2, they won't teach you period 5, won't test you period 4. It's always period 3. Because my J1, J2, my poly students, my university time, it was always period 3. Al2O3 is the one that's amphoteric we learn, and from here the rest are acidic. Give me the formula. Silicon, what is the formula of the oxide? SiO2. Phosphorus there? P2O4? That's not a common one. P4O10. Back to bonding. Sulfur, we learn sulfur, SO3. Chlorine by right now in syllabus, but if I forced you to write the common one, the balance. I think I can get this element to be balanced. All right. This is out of syllabus. Dot and cross diagram. Huh? This one? Become bleach. Is it true? I forgot already. Is it true? HPCl. Argon, all right, they are inert, so we won't react with oxide. Okay, so again, general trend. All right, so the nature of oxide, there is a trend over here. All right, so what's the trend once again? From basic oxide, you move across, amphoteric, it becomes acidic. Consider done. Now, what other trends we saw? Elements in the same group. Group means vertical row, right? They will have the same group number, all right, and same number of valence electrons. The way they react will also be the same, meaning they form ions with similar formula, they form compound with similar formula. Common sense. Elements that's in the same period, whether period 2, period 1, or period 3, we will say they have the same number of electron shells. The number of electron shell also give you the period number. All right, so this is a general feature. And again, based on bonding, everyone should also have a good feel that group 1, group 2, and group 3, they tend to form ions and therefore ionic compound with the charge. Your group 16 and 17, once again, they have like 6 to 7 valence electron. They tend to easily take in 1 or 2 electrons to form these ions. These are the example. Your group 18, basically, they do not react most of the time. In our syllabus, they don't react. The one in the middle, like not here, not there, they got 4 to 5 valence electron. So they tend to form what? Your carbon, your phosphorus tend to form covalent compounds. And therefore usually don't form ions. All right. So again, everyone should know this. Now, as you go down the group, every group is a fact that the atomic or the proton number will increase. The number get bigger. Take a look, periodic table, you can see. You should also appreciate that the atoms become bigger in size. Why is it bigger? The atom, because there's more electron shells. If you keep it simple, there are more electron shells, right? It looks bigger. I want to add in one more. As you go down the group, every group, what do you think about the metallic character? I saw this a few times these days in exam. Very weird. So this I can also apply to group 17, the non-metal one. But I just ask you, do you think about the metallic character? Yeah, metallic character is gain electrons or lose electron. Wait, lose. You say lose or gain? Lose, okay? The ease of losing electrons. So let's use group 1 for example. We have lithium, we have sodium, we have magnesium. What magnesium? Potassium. Correct? So what is the difference, right? We know that they become bigger. Agree? Let me have some space. More reactive. Yeah. That's what we're going to talk about later. Next week. They become bigger, right? Ladies and gentlemen? Correct? The valence shell, right? Okay. So take a look. We want to lose this electron. Make sense? Do you think by going down the group, is easier or more difficult to lose the electron? It's easier to lose. Why? Because the attraction here to the nucleus is further, less attracted. Here is more attracted. Can you see? To the positive nucleus in the middle. Because nearer, more attracted. And over here, this further, less attracted. Make sense? Less attracted, therefore means what? Means easier to lose or need less energy. Come on, finishing already. Easier to lose valence electron means what? Means the metallic character increases or decreases? Increases. My time, we seldom see this metallic character being asked this way. It's very common in school these days. Is that why some isotopes of uranium are unstable? That one I can't remember. I think it's due to a different reason. Uranium. I cannot commit to that. Ask me, Sean. Right? I'm not sure. Sorry. Okay, I'm not sure. Okay, so again, I talk about metallic character. So the metallic character increases as you go down group 1. Okay? If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.